that it doesn't really make sense to make an independence assumption here. So what's different between probability theory and fuzzy logic is that fuzzy logic is a logic in the sense that it has a truth functionality. The degree of fulfillment of a statement which is composed of other smaller statements is a function of the truth values of those smaller statements. Whereas in probability theory, it's not a function, the probability of, say, a co-occurrence is not a function of the probabilities of the occurrences of the events, but it's a function of what's actually going on. You actually have to look at the events and whether they are independent and justify those assumptions. And those assumptions tend to be really hard to justify for doing linguistic stuff. So this is the theoretic part of the talk, which then concludes the whole thing. And at this point, I want to remind you once again that why I'm standing here is because I really want to inspire some of you guys to go away and maybe do some technology transfer and maybe employ this kind of stuff in a useful way. So if at any time during this talk you've said to yourself, wow, this sounds like fun, I can think of a cool application where I can plug this stuff in, then please do feel free to come and see me afterwards, and I'll be happy to collaborate with any of you on cool projects involving this kind of stuff. So at this point, I'll say thanks for your attention, and I'll be happy to answer any questions.
Well, thanks, Richard. There was a question back there quite a while ago.
One thing that came to mind was search engines for the internet. Mm-hmm. But I'm not sure if it really fits, because in your examples at least, the domain was always very well defined. You said we had one domain, skyscrapers, and the other domain was cities. And as a result, you can get the non-contradiction within one person. That is one thing you pointed out. If you ask one person, is a city big or small, it does not contradict itself on a scale of the largeness of the city, of the population. But if you're not certain that the two questions rely to the same domain, this does not hold any longer.
Yeah, exactly. So in linguistics in general, or in computational linguistics, one of the very basic distinctions that is made is between open domain stuff and closed domain stuff. So this is closed domain in the sense that we relate a linguistic expression to a certain model. So the model defines our meaning, and we want to find out the meaning of the expression by drawing the connections there. And the open domain stuff, like with internet search engines, or all of the stuff that doesn't need any knowledge about what's going on, doesn't work by relating the expression to a model, but relating expressions to each other. So what Google does is you give it a query, you give it your information need in natural language, and it has these web pages out there which are also written in natural language. So there is no point at which Google actually understands your information need. All Google does is that it matches the query to the document. So I'm actually working right now. So this was my master's thesis, and I now go on to do PhD. And what I'm doing now is that I try to translate this stuff to the open domain setting, in which we try to use the fuzzy logic and the fuzzy semantics ideas to come up with a good way of comparing documents, or comparing a query to a document in an open domain way. But this is sort of non-trivial. We can talk about my approaches to doing this afterwards, but for this work, it's very much outside the scope.
I think that regarding, again, internet and Google, that if you train your audience how to put a query, then you can use Google's indexing system so that it's easier to find out the fuzzy logic answer for the queries. point one, and Jimmy Wales, the founder of Wikipedia, is now starting a new search engine called, now I don't remember. And anyway, so he wants the work of every user put inside, so they shall check whether the ranking of the answers are good or not, relevant or not. So, and with these answers, he hopes that the ranking shall be better. So maybe this is also useful advice so that people can make an input into the ranking, and so maybe then not by fuzzy logic, but by what was this? Picking up a coin.
Yeah, probability theory.
Yeah, probability. So maybe with these two methods, it helps to refine your answers. Thank you.
Yeah, with probability, it's. I mean, part of the whole business of doing search engines is that you don't only have the linguistic criterion of how well does the query match the content of a web page. You also have an a priori criterion of how good is a web page in itself. So there are web pages out there which are just crap, and there's no way that anyone could be interested in anything that's on there. And the way Google does this is of course by doing PageRank and by giving it PageRank scores by looking at how the pages are linked to each other. And this is not always the case for doing linguistic stuff. And then another part of doing the search engine stuff is that you very much have to worry about what your index looks like and whether you can quickly search the index and whether your index supports all the search functions that you want to do. If you look at those logical forms, then you will see that the logical forms actually more or less add information into what's described, and the logical forms will actually take more space than the actual web page. So if you imagine that Google wants to do this, this means they would have to have an index that's larger than the web itself, which is definitely one of the I mean, Google has a lot of money, but seriously, they can't do this. Yeah, it's very much about search engine technology is, from a linguistic point of view, still very far from what can be done in terms of really understanding stuff in a natural language processing kind of way. And this is due to some inherent restrictions of building search engines. So this is not the primary target that I see for this kind of technology.
Okay, back question to the adjectives. If there are some unknown adjectives in the query, is it possible to ask the user back, what do you mean with hot city or with snowy city? I don't know. Is there some approaches?
Yeah, from the general idea, if you have multiple ways of defining, for example, a big city, could be defined in terms of the population of the city, in terms of the area of the city, or maybe in terms of the average number of Starbucks per square meter. So if you want to disambiguate this kind of stuff, then naturally what you would do is you would just put 3 lexical entries with the same word in the model, and that will give you an ambiguity. And the way you resolve this ambiguity could be by asking, for example, the user. But we've not done this for one reason, is because we argue that, first of all, we don't really need it for the proof of concept kind of deal we're doing. And the other thing is that we make the assumption that people will naturally assume a frame of reference or whatever. So you give them the experiment and you ask them, a city with population such and such, is that big or not? So people will automatically make certain assumptions about what you mean by big. And then by collecting the data in such a way, that means that at the end of the day in the natural language database interface, the computer will make the same sort of assumptions that the human users have done. So asking back is definitely a possibility, but it is not something that we've directly implemented here.
I have a question put in between. One problem with natural language processing in open source is that usually the linguistic resources are published under, well, if they are published at all, then the licenses are just crazy. So you basically can't do much with the linguistic resources. Now you've mentioned this LRG or what it was.
Yeah, exactly.
What license is it under?
Yeah, so as I've said, the ERG, including its lexicon and everything else, is so this all came out of an EU project actually at some point, or it was an older project, and then at one point it was converted into an EU project. Anyway, it's called Delphin, so the URL is www.delph-in.net. And I think it's cited in my paper linked to this anyway. So this was done by Stanford, and it's open source in the sense that it's redistributed under the LGPL. So you can just plug it into any sort of open source software that you want to do. You can even plug it into commercial software. And the same thing goes for the LKB. Now, the LKB is also distributed freely under the LGPL, but one thing you have to be aware of is that it's written in Lisp. Not my idea.
I have a question. Is it possible to use such a database to understand, in quotation marks, text? For example, if you read law text, it's written, for example, if you do this, then you will be punished with that. Or if somebody does this, the consequences will be that. And thousands of hyperlinks. So because they say, look in paragraph something, and you have to check this and this. So is it possible to put all this text into a database and to do some data mining so that a normal person can understand law text? So for example, if you bought something, you will know, you want to know, do I have a possibility to get my money back or something? So you put in the question into the machine, and it does something, and then you have a possibility, because it's fuzzy, from maybe 80% that you get your money back because of paragraph something, and then you get the report, go to your dealer and say, the chances are very good to get my money back.
Yeah, so what I've done in this work is that I've assumed the database is kind of there, and there can be a knowledge base like in between the database and the question answering stuff. Now your question relates to, you have this text of law, and now how do you understand the law and put it into the database? So that's sort of the other way around. And this is actually handled under the name information extraction. So there has been work going on in that field for quite some time now. And it's about extracting ontological relationships. So if you're talking about law, then one of the stereotypical relationship can be like a cause-effect or a situation-punishment type of tuple. And there is some very interesting work on this using the same linguistic infrastructure that's available on LGPL. That's done by Aurélie Herbelot. So if you look at the webpage describing this talk, there is a link to the natural language group at Cambridge, and Aurélie Herbelot is a PhD student doing work on information extraction particularly. If you ask the question, how good is it, then the primary resource is TREC, the Text Retrieval Conference. And that's a conference that's done once a year, and it does competitive evaluation. So it gives people one interface saying that this is what a program looks like that does information extraction. And then they go out and collect all sorts of data, like they have poor humans sitting there for weeks, all day long, tagging that, okay, there is, in this piece of text, we have this relationship, and then we have this relationship. And then you get a whole sort of data, and then you let the computer do the same thing, and you look at whether stuff matches. So they do that competitively, so research groups around the world submit their programs, and then they look at what sort of percentage agreement you get. So if you just Google for TREC, T-R-E-C, then you will get the results for the last year, and you can look at what the evaluation was like and what the sort of numbers they got.
How far is the way to have such a lawyer for open source lawyer that does not cost something?
I think that's probably an AI complete problem, actually. So if you can build the open source lawyer, you can probably build hell. But on a more shallow level, there's a lot of stuff that you can do to support people in to support lawyers to do their work more easily or in our case, to support just smart people like hackers in educating themselves about law and